In this video, we are going to create or learn how to create a linked list, and we will be using the C programming language. And what is a linked list? A linked list is a linear data structure that is a set of nodes allocated dynamically in memory. The nodes consist of two parts, the data and the link is the pointer to the next node of the list. And this picture is a pictorial representation of what a linked list looks like. A linked list is often compared to an array, but unlike array, which is contiguous in memory, the nodes in a linked list are scattered in the heap memory. So why use a linked list over an array? Well, one reason is because an array is fixed in size. That's partly because the data is or can only be stored in a contiguous block of memory. This means that the size cannot be altered at runtime. We have to know ahead of time the upper limit of the number of elements. A linked list, on the other hand, the nodes are scattered in memory and it's not in fixed size, so it's more dynamic. You can change the memory size at runtime to meet the requirements for your data. Inserting a new element in an array can get messy in order to maintain a sorted list. We must move all of the elements in order to sort them. And when we want to insert an element at the beginning of an array, what if it has over 1,000 elements? To do this, we have to shift all of the elements towards the right as shown in this picture to create a space in the first position. And the time complexity of this is O of n because we have to go through every single one of the elements. A linked list, on the other hand, we can just create a new node and add it to the first node. But the time complexity of this is constant, it's O of 1. On the other hand, an array does have some advantages because when you're inserting an element at the end, assuming that the array is not full, the time complexity is O of 1. Whereas to insert an element at the end of a linked list, we have to traverse, meaning we have to visit each element of the whole list, and the time complexity is O of n. Likewise, when inserting a position to the end position, or anywhere in the middle, the time complexity for both an array and a linked list would be O of n, because we have to visit each node or each element and find our location. For an array, we have to shift the elements to the right, and in the linked list, we have to traverse to that position. But unlike an array, in a linked list, we don't have to perform any form of shifting. So arrays takes more time while performing any operation like insertion and deletion, whereas linked list takes less time when performing the same operation. A linked list allows for dynamic size that can change or be modified at runtime. In other words, a linked list can increase in size to require the amount of data that a programmer would need. An array can be directly accessed with its index, which is nice, whereas in the case of a linked list, we have to traverse each element to reach our particular element. In an array, memory is allocated at compile time. In a linked list, memory is allocated at runtime. Memory utilization is inefficient for arrays. Linked list, on the other hand, is more efficient. There are three types of linked lists. There's a singly linked list, and with a singly linked list, the navigation is forward, and this is an example of single linked list. A doubling linked list, the navigation is forward and backwards, so you can go forward or you can go backward. Finally, there's a circular linked list, where the last element is linked to the first element. So you're going forward, and here, once you reach your last element, you are linked back to the first element.